I have no slides, okay? It was not prepared, nothing, so I'm just showing. The only thing I prepared is the numbers in front of the unit test, so I can order the unit test for you. So what is it about? Everyone knows what an ORM is. Object Relational Mapper. Laura knows, so everyone knows, okay? Good. So an ORM is to take objects and store them in relational databases, okay? Map objects to tables. YesSql is the name of the thing I will show you. It's not an ORM. It's something I just invented called a DRM. It doesn't, well, DRM is not a concept which exists. It's like, it just, if you know what an ORM is, no, actually, it's
digital rights management.
No, it's not. It's not even that. So YesSql is a library which is on GitHub. There is no website. There is a nice README that explains what it is, and this will be my slide. So YesSql is a .NET document database, a .NET document database interface for relational databases. So you take a .NET object and it will store it as a document, one JSON document, into a relational database. Because in SQL, we trust, okay? Issue being, if you want to store documents somewhere in a store, you can use document databases, MongoDB, CouchDB, whatever, all the ones you know. There are issues with those. Technical issues and political issues with those. Technical issues are, most of them are not transactional. So if you want to store two documents in the same collection, it will work. But if you want to store one document and one view or one change and something else from another collection, it won't be transactional. So in Orchard, because we have modules which are totally different and can both save something different but have to be part of the same transaction, we can't use this. For instance, we can't use MongoDB because of that. MongoDB is not transactional, so we can't use that. RavenDB is in .NET, but that's not an issue, and is transactional and is a document database, but it's not free. We will have to pay. Well, as a developer, we will not have to pay, but once we go in production, we'll have to pay for his license for RavenDB. So that's not the best solution. So there is always issue. And then there are the political issues. When you use MongoDB or whatever, FooDB, which is a document database, your management or your company might not agree with that because you have invested in SQL, in PostgreSQL, MySQL, in SQL Server, so you know stuff. You have that. You have how do you call them? DBAs, database administrators, and you know SQL and you know it works. Okay, and so maybe you have bet on SQL and you still want to use the SQL licenses you're using, and also maybe you want something which is embedded that doesn't need to be set up. Like SQL Server, you have to set up a SQL Server instance and use it. Okay, so if you want some embedded development, like on a phone or without database, like a website and a SQLite file, for instance, you can't do it with a document database because I don't know if there exists such things. There are, but they are not as ubiquitous. Sergio will tell you the name of one embedded database, document database.
JSQL?
Maybe. I didn't understand what he said, but there is one. And but so for all these reasons, SQL is still a good solution because it's transactional. There are free solutions. You know the stuff. You know this stuff. It works. There are hosting providers for that. And embedded solutions like SQLite, PostgreSQL, MySQL, SQL Server, whatever you want. So YesSql is here to let you expose a document-like interface to store documents into a relational database. Okay, that's the idea. So like an ORM takes your objects into a relational database, this one takes your object into documents into a relational database. So ODRM is better. Object to document to relational database. And the opposite way. So how it works. So the simple concept is that it's called YesSql because it's not about NoSQL. It's still SQL, but YesSql. How does it work? So YesSql is a library like anti-framework, like an Hibernate, that will let you pass some raw objects, POCOs, like your classes that you want to serialize, and we'll store them, serialize them in JSON, and store a JSON document into one table, into one column of one table. Okay, and every I will close. Outlook is closed, so I don't get it. Okay, and yeah, so every object will be represented by one record in a database, in a database table. Okay, so this is to store things, and YesSql allows you also to query these objects, because if you have a JSON string in a SQL database, you can't query anything from this JSON document. Okay, no, you can do likes, but no, that doesn't work. You don't want to do that. So what it will also do, it will create indexes or views out of these objects, these JSON documents, and views that you can query based on the things you actually want to query. So if you have an object with 1,000 properties, but you actually just want to query by name, well, it will create a table with a name column corresponding to the name property of your JSON document. So we'll actually project the JSON document interesting properties or queryable properties into specific tables. So now your tables are actually used as indexes to query your documents, not to store the document, but just to query them. That's why you can call it an index. It doesn't relate to the fact that a table actually has also SQL indexes. There are different index things. I will use indexes, but Zoltan will always correct me to say I should use indices. He's right, but I use indexes. I'm abusing the language, but that's fine. Everyone understands. So that's how it works. And with YesSql, you can define two kinds of indexes. You can define the MapReduce indexes, which is a one-to-one mapping between a JSON document and a record that contains values. Like if I have a person object, it has a name and an age. If I map a person to name and age queryable, then I will have one index per person. Okay? One person, one index with its properties. Another person, another index record. Okay? So each object will get one index record. And there are also MapReduce indexes, which will map one index for many documents. Example, if we want to compute the archive of something for a specific day, we have many blog posts, for instance, or many things. So we use a MapReduce to take many items and merge them into one index, to count things, to sum things, to average things, okay? And that's how you can do that. So map index and reduce indexes. So now let me show you how it works. So this is the project I'm developing in, and you can see that YesSql supports MySQL, PostgreSQL, SQLite, and SQL Server. Not from long ago, but if you go to the meeting, you know when. And it also has in-memory test and Lightning DB test. So the idea with YesSql is that it separates the API which can store documents in anything, and the API which can query documents using indexes from SQL databases. Okay? And when you store document in anything, it can literally be anything, because storing the JSON document doesn't have to be in a SQL database. It can be anywhere. Querying a SQL table has to be in a SQL database. That's the separation. By default, you can use the same database to both store your documents and query the indexes. Okay? But these samples, these tests, they will just run in various storage engines like memory to store your documents in memory only, or this flat file format because why not? And that will work too. Azure blobs, that works too. But querying will be in a SQL database. But yeah, later. So these are the unit tests I run to see how it works. So what I have in this project, I have many kinds of POCOs, like I have a person class. Everyone will understand this one. First name, last name, okay? Bill Gates, well-known guy. And this is a POCO. So I will show it after. So if in this test you see I have a store. A store is like in an Hibernate, what is it called? Session factory. Session factory in an Hibernate or a context in Entity Framework is like a store I store in YesSql. So it's a singleton that contains the configuration and the connection strings to the database. And to create a store, you just say new store and you give it a connection string, and you have a store. Good. And every time you want to communicate and to create a transaction or to create a request that goes to the database, you do create session, like I assume in an Hibernate. I don't remember. I assume it's the same. And you get a session object, like in an Hibernate. And this object is disposable. So whenever you dispose it, the transaction or all the requests associated, all the queries associated to this session will be committed. So for every session that is a transaction, when you dispose the object and there is no exception or nothing, it will be committed to the database. Okay, so it's like a transaction for read and for write. So I create a session, and with this session I create an object which has nothing special, and I say session.save bill. And at that point, when it's disposed, it will create a JSON document in the database. And this store, if I look into the unit tests on initialization, which must be in the constructor, nope. It must be somewhere, right? Nope. Oh yes, maybe this one. Yeah. Store initialize async will create the necessary. It's like data migration. It will create the necessary tables in the SQL database, and you can also have access to migration-like APIs where you can create tables for your indexes with the columns that you want and everything. It's like migration in Orchard. The same API to create manipulate tables, to create your index tables, the document tables, and so on. But let's say it's a migration step. We don't care in this case. So my tables are created, and I can just say create session to get session and save my object. And when you run that, I will run it. 0, 1. Run. I can't run it from here because this class is a base class. It doesn't know which database to use. I have a class for each database here to use. And if I go to SQL Server and I look in a YesSql table, no, it's the TempDB, sorry. System table, TempDB. It created all these tables because my unit test needs all these tables, my unit tests, but this one doesn't require everything. This unit test only requires the document table. The document table is where we store what has been saved. It knows, oh, there is a, can you see? I don't know how to zoom for this thing. Now you can see better. So there is one record now in my database, which is the type of the object I serialize and an identifier. So this is just a record to say there is something. And the content is actually in this table, because the content can be anywhere. In my configuration, I decided to use a table called content to store the JSON object. And you see first name Bill, last name Gates, age 0, because there is an age property also on the, okay? So it's just a JSON document in a database. And I can save many of them if I want. A new session, one person, Steve Ballmer. I should use Satya, but I don't know, when I started the project, Satya was not yet here. And Bill and Steve save, and you will have, so if I run this here, this is obvious. It's an unprepared session just in the meantime, that's why. So if I run this now in the table, I will have 2 JSON objects, okay? Simple. So it can be anything, just serializing using JSON. But it can also be not only anything, but anonymous objects. You see? Here, there is no class, it's just an anonymous object, and it will save the same thing. It's just that the record in the document table will have anonymous or something, I don't even know what it is, but who cares? That will work. Then you can load things. So to load things, you create a session. Here it will save a complex object, so you see I have properties, I also have an address object, and it will be saved correctly. I save the object. When it's disposed, the transaction is committed. I create a new transaction. And here, on the session, you can do query async and say any to filter any type, like give me anything, any type, and first or default. And because we only saved one object, we expect this object to be returned. Okay, and because it's an anonymous object, I'm loading it as a dynamic object. I don't know the type, so I'm just getting a dynamic object. And here the test just says, okay, we need the first name to be Bill Gates and the address. So because this object has first name, last name, address, so if I run it, every time I run a test, the database is cleared. Okay, so if I do again this, well, it's supposed to be cleared. Because I need to run number 4. And I have this object, you see, with the complex type. And if I look at the document table, it should be it's called dynamic. Okay, it's clever. This must be a custom case, like if I see it's an anonymous object, then I just put dynamic, so I don't try to resolve any type to deserialize. I just deserialize it as dynamic. And this is why we get a dynamic here back when we do the test. So it's not even linked to any schema that you have to specify, it's just a JSON document. So that's why you use document DBs, because maybe you don't want any schema in your JSON object, and that's fine. So serialized complex object is the same thing, it's just that here I'm explicitly using a class which has other sub-properties and can be anything. So nothing here interesting compared to what you saw before. The thing interesting here is that with session, you can query anything. You can also get a specific ID. Okay, so if you have the identifier of an object, you can query this object by this identifier and get the type of the object back. You say, give me the product with this product ID, and you get the product. So a simple select where ID equals foo, and you get directly the object with one query, okay? Even if it's a complex object. So for Orchard, it's very important to have a document database, because our content items, they are made of lots of small parts, which in Orchard 1 are spread across lots of tables. And when we want to load one object, we need to do either lots of queries or lots of joins. So it's either slow or slow. And that's how relational works. But at the same time, it's very flexible, because we can do joins, we can just load the part if we want, so that's good. But for a content management system, it's not the best solution. The best solution is to have a document to be stored. So when we load a content item, we get all its properties and sub-parts of properties, because maybe the content item doesn't know anything about the thing, so it can't define a schema, so it can just be a dynamic set of elements, of values, of properties, of objects. And we want that to be a single query if possible, without joins, so faster. So this one is just nothing interesting. This one is just showing that once you save something, once you call save, it will assign an ID to the object that you are saving. So we can track the object is marked for save, for all. I want to use the word save. So, and then you can check the ID is there. That's it, nothing interesting. This one is very interesting. This is what an IBRN has, and that we configured a few years ago to do by default. Autoflash. Autoflash. So I create a session, I have my Bill Gates, I save Bill Gates, and then at that point, it's marked for save all, but it's not saved yet, okay? So, but when we do a query, we want to create something that might be saved later. So what it does is that when we do a query using a session, and in this session there are things to be done, okay, when it will be disposed, like updating, deleting, saving, whatever, it will flush the existing SQL queries to the database without committing a transaction. Just we have a bunch of SQL that are pending. Save will just, oh, you will need to do that. Okay. But instead of waiting for this post to be called, the query will trigger a flush. So all the queries will go to the database, and then we can do the actual read query and get the object. So you can see here that this object is marked for save all, and we do get async build.id because at this point we have the ID of this object, and this guy returns the object from database. And not only that, but we ensure that new bill and bill, so the object which is to be saved and the object which is loaded, are actually the same object instance. Okay, they are not two objects representing the same bill, they are the same object. The two references point to the same object because of what we call a first level cache, which is or identity map in some other ORMs. So it's a map of all the objects by ID, so that when we load something, if we already have it in memory, we gave the value which is in memory. So that's the Autoflash. Then should keep track on Autoflash, we don't care. This one will show you how to query on indexes. So far we've just used the document storage, just to show how to store a JSON document. This one will show how to query things based on indexes and what an index is, what an index space is. So here, to use indexes, you could say that if I use indices, there will not be any issues with index is, but I don't. Register indexes will provide to the store some configuration about how to manipulate a person when it's saved. So this class is an index provider. If I look at it, an index provider inherits from index provider of something. So it just say that when this something is saved or updated, you need to run this index projection, map reduce or map logic. So this index provider says whenever a person is updated, you return a person by name. This is the name of the index. This is the provider, and this is the index, the actual index. The actual record that will be stored in a different table representing the index of the person object. And this index will be created for each person by saying create a new person by name, and the name property of this index will be the first name property of the person. So my person object has a first name, a last name, and an age. I want to query my person objects by their first name. So it will create for each person a person by name object, which itself has a property name. So I will just map the first name of the person to the name of the person by name. Okay? For each person, I will have one object person by name. The first name of the person will be the name of the person by name. So I'm duplicating the data from the person object into another object. But this other object will be queryable because my JSON data here is not queryable. This one will. So it's a projection, one-to-one projection. And this is the class that represents the index. It's a map index, just to say that this thing, there will be one person by name for each person. So now back to the unit test. I'm just registering the provider, and I'm creating two person objects, Bill and Steve, and save them. And now, in a new session, in a new transaction, the test is to query an index, and I can only pass an index type here. I'm not querying a person, an object, a document. I'm querying the index itself. It's like I have my document with all my JSON, and I have a table, or let me run that to show you. Test number 8. So if I go to database, I should have two documents, okay, of type person. They should be Bill and Steve in the documents table. They are there. You understand I can't query that with SQL Server. It's a string. Well, yes, it's a string. And what I have in the tables is something called person by name. So for each index defined in YesSql, we have a table with only the columns from the index class, like name. And you see here, I projected Bill, the first name of the person, into name, the name property of the person by name. Same thing for Steve. And this is the document ID. So this is the object ID, and this is the object ID of this record. Okay, it's a relationship to the document table. It's a one-to-one. It's very easy. So the join here is between the document ID, which is a primary key, to this one, which is a foreign key. Okay, it's very straightforward. And they're just integers, so it can be faster with a join. And at least I don't even need a join. If I just want to know how many person by name do you have with the name Bill? Well, you just query this table with Bill. This is what it's doing. It's saying query all the person by name and give me the count. So select star from person by name.
Can you show the person by name class?
Right.
So it will take all the properties and
It's serialized, yes. It's an automatic mapping of your index class into a table. So any property here will be mapped to a column. But you define explicitly the table columns using migrations, like create map index table, add column name, add column foo, add column, like in Orchard. So here, I'm doing a count on all the person by name. So select star from person by name, select count star from person by name. Just count them. And it will just return 2 because there are 2 items in this table. Here it's saying give me the person by name object, which has the name Bill. So very simple, it will return this thing with the Bill value, okay? So here it's not interesting because we are querying the index itself. But then what we can do is saying, query a thing, not the index, query a person with or by its person by name. Remember, the document table is linked to the person table, to the person by name table. So it will do a join between the document table and the person by name table and extract that. So what we're actually saying is that give me a document whose person by name is Bill and give it to me as a person. So deserialize it as a person. And then what we have here is a person object. So we are querying the person JSON document by one of the properties which have been mapped to the person by name object, okay, using link. So this link query, this link expression will be converted to a SQL query over person by name, okay, and we get the first or default. And in the end, we have a person and its first name is Bill, okay. So this is how it works. We can query JSON document because we are projecting its properties, any property we want, and only the properties we want, into a table which we can query. And this will be super fast because our table is just made of stuff that can be queried, and we can even index in SQL terms these tables and these columns because they are just there for being queried. So it's easier to create indexes and fast queries. So should append index on update. This one is about showing what happens to the indexes when I change the objects. So if I create a new person and I create the indexes, but then afterward I update this person, my index should be also updated. So what happens here is I create a person Bill Gates, I save it, and I ensure that I'm loading one and we have one person, okay, good. I'm saving Bill 2. Oh, I load, okay, Bill is saved. Then I'm checking that we have the index, okay? Because it's auto-flushed. Then I change Bill. It's called Bill 2 now. And I save Bill. So what we need to check is when we load the person by name index, it should be the same document ID, okay, good. That's what it tests. Then it changes to Bill 3. It updates because we are querying, and it checks that no, that's not the test. Okay, the test is about, okay, append index on update, and I explain why. It creates new records. So it's just checking that whenever an index is created or updated, it increments its identifier. So even though the index is representing the same object, we are incrementing the identifier, so it's a new record, because this way it's very interesting to get some journal about what has been done. So if you want a processor of indexes, because the ID is incrementing, you can have your processor which says, oh, there is a new thing to process because it's a new ID, and you will process it again. Like you can detect changes. If we use the same ID, there is no way to know that this index has changed. Okay, so it's like a timestamp. We are using the ID as a timestamp, so it's just a trick. It's very useful, in our thread at least. So this test was just about it. But just think that if I run it, you will see what is interesting here. That's not what I wanted to do. It might be the default database, so it might work. It's not number anything. So I was not supposed to show it. Okay, that's why. Okay, this one I was supposed to show. Should create several map indexes per document. Oh, this one, yeah, I won't show it. That's okay. So this one is about explaining that when I said one person is one map index, I was wrong actually. It's one person can be multiple map indexes. Example, here I'm creating a person called Scott Enselman, and I'm creating another person called Scott Guthrie. What's in common? They are rich, but they also named Scott. I'm kidding. They are talented and named Scott. And I save them. And what I have here is I'm registering a person identities index provider. What does it do? It takes a person, and for each of them, it returns an array of person identity. And this person identity is just a string identity. But I assign the first name and the last name of each person identity. So for each person, I will have two person identity records, one with the first name, one with the last name as their identity. Okay? So I will get 4 records. Scott, Enselman, Scott, Guthrie, 4 of them. Okay? It's like, imagine you have a text and you want to map each word to a value in a column, like indexing, like full text indexing. You will extract every word and you will have one record in your index for each of the words. Okay? It's not exactly that yet. It's more a reduced thing, but it's the idea. You can, from one thing, get multiple indexes to find all the occurrences of these things. So here, I'm saving them with this specific one, and I'm ensuring that I have 4 person identity records. I'm ensuring that only one of these identities has the value identity Enselman, only one has the value identity Guthrie, and 2 of them, identities, are Scott. So if I run that, it's number 10. I don't have anything in this table because this is a person by name. I'm not using it. I should have 2 documents, and I should have in the person identity Scott, Enselman, Scott, and Guthrie. So we could use this table as is, like, oh, give me all the parts of the names of any person, and I could just query this column, and I have everything I need. I can also use that to link to existing documents, and that's good. And you see, that's why we have a document ID and an ID, because this thing and this thing actually represent the same document. Okay? But they are 2 different person identities. And I will show you 2 last things, joining indexes and map reduce, which is another type of index. So join map indexes. So we have to see an index as a projection of your document into a concept, like a part somehow, which can be independent. So this one is a person index provider, which is just the one we've seen with a name. Okay, I can get the name of something. I could have called it name part provider. And person age, which will give me the age of something. It also has name and adult, whatever, but it's interesting here it has age, and it can compute things. It's not about just putting a value into something else. It's also about manipulating, counting, filtering, because here you could say if something, return that, or don't return anything. You could even have a person which doesn't map to anything. So you can pre-filter your documents based on a condition. So when you do the query, you are sure that when you do the query, it's already filtered, like published documents. I could have an index with only the published documents. So when I do a query on this table, I don't have to cope with the index over everything which is not published, because I want published things. It can already pre-filtered, so it's faster for published things. So in this case, I'm computing a value which is adult or not. You are an adult if you are more than 18. So I can say, give me everyone who is an adult. Okay? And this way, I don't have to do a comparison in everything of my database, at least an integer comparison, but just a Boolean comparison, or whatever you want, a concatenation, things like this, whatever you want. It's just projecting. So in this case, I have two indexes for the same object. So when I save a person here, I will have one person index and one person age. And this sample is to show you, so I have Bill, Steve, and Paul. Paul who?
Alan.
Thank you, Steve. He pays more taxes for his house than you will ever make money. Okay. I think it's 10 million per year for just his main house of taxes, just taxes, 10 million. This is the most in Mercer Island. So in the full, it's public data. So just saying. So I'm saying Bill, Steve, and Paul. So we have Bill, Steve, and Paul, age 1, age 2, age 2. Okay? Just a test. Here I'm saying, give me all the person by name. I have 3. Give me all the person by age with age equals 2. We have 2. Give a person, and here is interesting, with, so we are not using the simple person comma person by name, we want to use 2 indexes here. So a person whose person by name is Steve and person by age is 2. Okay, and we have a new one. So it will do a join between 2 indexes, but it's an opt-in join. If we really want 2 things to be joined against, we will use that. That's how it works, and you trust me. And the last test I want to show you is a reduce. Do I have a 12 something? Should reduce. So an article index provider has a count and a day of year. So you can see the idea of a reduce index. I'm creating here for each article. Okay, we want to, and you will see what the idea is, but you don't care here. I'm creating a new article by day. So a map reduce is 2 phases. First, we map each object into another one, and then this other one, which is a map index, will be reduced by using an aggregation operator. So first thing, for each article, give me an article by day, which will be computing, initialize the count and the day of year of the article. So I'm taking the published of the article, the day of the year, like 1, 2, 3, up to 365, okay? Which day was this article created or published? So I'm creating 1 to 1. And then what it will do, it will group all the articles by day of year, okay? And the result will be the key of the group, which I will use as day of year, and the count of the things which are being grouped, which I will sum to the actual value of the current count. That's how MapReduce works. You take a bunch of this algorithm. Imagine you have 1,000 articles. The idea with this algorithm is that you can take 1,000 articles and do this operation. You will get the count summed, which will be count of 1 times 1,000, so 1,000. Or you can split it into 10 different processes, and you will get 10, 10, 10, 10, 10, or 100, 110 times, and you have another set of reduce, and you can reduce again and again. So you can parallelize reduce works. That's how the logic works. But that's not what we are doing, but that's why map reduce is map, group, and reduce. And delete is just optionally when you remove an article, it's an optimized way of removing stuff from a reduce index. When you don't want to reprocess the 1,000 articles because you removed one, you just apply that to update the reduce index. It's just an implementation detail. But what is interesting here is that you have a map reduce algorithm to group stuff. So the test is, let's create 10 dates. Let's iterate over the dates and create a new article with the published of the date. The date is November 1, 2, 3, 4, 1, 2, 3, 1, 2, and 1. So we have 4 articles for the 1, 3 for the 2, 2 for the 3, 1 for the 4. Okay? I publish the articles. I have 10 articles with 4 different dates. And then we check that we have 4 articles by day because they're just grouped. We have 4 articles by day indexes. I will run it just to show you. 12. This will be my last example. I'm not even sure you understand what's happening. I hope. So an article by day index is one record for each value, distinct value of day of year. Okay? And here is the property count that I count by summing up every value of count for each map index. So if I have 4 articles, I have 4 articles by day. I sum them, I have 4 in the count. Okay, which means I have 4 articles, which for the day 305. I have 3 articles for the day 306. 1st of November, 2nd of November, 3rd of November, 4th of November. Okay, that's how it works. And then I'm checking that I have 1 article by day with the value day of year of the 1st of November and so on. That I have 4 articles by day. Well, yes, let's look at this query. This query is give me all the articles. So query I think an article by an index named articles by day. But this is a reduced article, a reduced index. So it doesn't return 1 document, but multiple. And I say give me for article by day, day of year of the 1st November, give me all the articles. I should have 4 articles. Okay? So you can query all the articles for a specific day now. And you don't have to compute again and again the articles. It's pre-computed. We know which articles are for this day. And the advantage also is that if tomorrow your code changes 1 article, YesSql will reproduce the correct value of the archive. In Orchard 1, we had to, every time we saved a document, we will ourselves get the correct archive record, change the value, remove it if it was in the previous archive. Like you change a blog post from November to September. You have to change 2 records of what? Of archive, whatever task, I don't remember. Here, it will do it for you. We won't mess up with that, okay? It will always be up to date, as long as we use the API to change the article. And that's the last test, but I won't run it. I assume the last test is about ensuring that when we have a reduced index or an index, if we update one of the documents which have been indexed, then all the indexes are updated. Even if it touches multiple indexes, it has to update them. That's what it ensures. So that's the idea. Store documents, so we don't have joins between parts for Orchard, and prefetch some indexes, queries for the read queries to be faster. Because the idea is that it's more work to do on writes, but it's less work to do on reads. So reads are faster than writes in this system. But for a CMS, this is what we want. We want reads to be faster than writes. We edit an article once, we read it 1 million times. Okay? So that's why it's optimized for. Questions?
Could we use something other than integers for IDs if we want?
No. But so it was one of the first thoughts. So the idea was to optimize the heck out of it. Whatever we could gain from optimizing anything. And I was like, so I wanted 2 things. To be fast, but also to have an ID defined on the client side. So we don't have to round trip to know the ID, okay, of something. So when I save, I know it will be persisted and I will know its ID. I don't have to save to get its ID. It's very important for CMSs because we can redirect the guy or before knowing it was saved already. So we need to know the ID. 2 solutions, 2.5 or whatever. GUIDs. We could use GUIDs. They are unique. They are fast to generate. But in the database, I could say I would assume, but I read articles saying integers are faster than GUIDs to manage. In SQL, maybe in SQL Server it's the same, I don't know. But in MySQL, in SQLite, and so on, we don't have the GUID type. They don't optimize it. For them, it's just a string. So finding the GUID by GUID is slower than integers because integers, they use that as primary keys live. Okay, so it's faster. That's why I'm like, okay, I need to find a solution with integers, as long as it's not a pain for the user. Okay, and but still generating on the client. How do you generate an integer which is unique on the client if you have many clients? even clients meaning request on a server. Okay, it's on a server, but so there are two algorithms that I know of. There is the, I don't know, and there is the high-low. No, there is the high-low. So an IBNet has this algorithm, and this is an adapted high-low. The idea is that whenever we create a session, the session will acquire a set of IDs to reassign, 20 by default. So the session says, store, give me the list of IDs I can use. And the store, because it's unique, will say, you can use these 20. Okay? A new session will arrive and say, which are the IDs I can use? Oh, you can use these 20. So these ones are for my session, and these ones are for my session. So they will increase, so like from 1 to 20, from 21 to 40. Okay? And whenever we get a list of IDs, the store will actually ask the database, what is the next available range for their client? And so we pre-generate IDs, but incremental IDs, to give to the clients, and they are assigned and associated on the client side, on the client connection. And this way, we are sure to have a unique ID and also an integer. There will be holes in the ID generation because you can have 1, 20, 40. If you create a new session every time and you don't create many objects, then yeah, you can get holes. And when I
right?
What?
They are recycled when they're not.
So no, but because we can't, this algorithm can't deal with. It's not like we have a table of available IDs. It's just giving the next 21 after the last one. But there are only holes if you restart the server every time. So every time you restart, you get a hole. So if I start my server, no, because the store is the store, which contains the list of available IDs, is not really giving 20. It's acquiring 20 for database, but giving 1 to the sessions, one at a time, okay, to the sessions. So if I start my server, the session will get 1, because it's using the same store. The second session will get 2, and so on, 3, 4, 5, 6, 7. But the store acquired 20. Sorry, I messed up. So the store acquired 20. If I stop at 10 and I restart my server, the database thinks that the next available list is from 21. So it will tell the store it's 21. So from 10 to 21, I'm lost. So
The session requires more than one ID?
No, the session talks to the store one by one, and the store is a singleton, so it's locked. So 2 sessions will ask one at a time. So 21, 22, 23, 24, 25, 26. And only if we restart, we will lose some IDs. And we will only lose by the range that we define in the configuration. The default is 20, and every 20, the store will do a request to the database to get the next available range. You can configure it to 1000 if you think that you never restart your site and you don't want to send a query to get the new ones. But imagine, it's a query to get an integer. Okay, it's an integer to get every time you saved 20 objects. That's fine. Because when you save objects, there are also lots of queries. So reading an integer is cheap 20 times. Okay, but you can change the number if you want. It could be 1. You can do 1. Every query, you create a database to get the next ID. I will not do that, but that's the idea. So, whatever you think. And it's that.
But it's really, so you can't generate these IDs without having a connection to the database in the first
Nope.
place. It's just that you get them in bulk from the database.
Yes. When you initialize the store with a connection and you say store.initialize, it will get the thing. So there is a table called linear ID generator or something like that contains for different dimensions, because we can have different collections in YesSql. So different document tables, and each document table has its own cursor. So we have a list of IDs for each of them. Yeah.
How do you handle property name change and property type change?
You pray that it works. And if you really want to do that, I think,
You may have.
yeah, I thought about it. So the idea is that what we will need ultimately, I'm not sure we will do that, because we have the same issue in Virtual One. If you change the property of an object, you need to execute a migration or execute a SQL script in your SQL database to change the values also, the type and everything. Same thing. But here, what we can do is assign a version to the object and kind of an event handler. So whenever an object is loaded, we can run data migration, but content migration on the JSON document. So you know this document is of version 1. So we need to change it, to tweak it, so that we change its property or its property name when it's given to the API. So it's still to be done. I'm not sure we'll do that, but that will be the solution if you wanted to do that. To integrate an event to say, I loaded a JSON object, what do you want to do on this object based on whatever you want? Like, transform it. That's the idea.
In some of the examples, you also stored the ID, the numerical ID of the document,
so the
JSON.
ID property is optionally on the POCO. If we find an ID property, we will get set it whenever you save the document or load the document. So you can know about the ID of the document. If you don't declare the ID property of the POCO, then you can't access it. That's good.
And couldn't you declare the ID property and automatically fill it from the ID column?
They are two different things. They are not two different things. What do you mean? Well, there is an ID property in the JSON document, right?
Yeah.
That's your question?
So my question is basically, is it necessary to store the document ID redundantly if you also want to access it from the outside?
We don't have to. You mean this one?
Yeah.
We don't have to, but it's more work to remove it than just letting it. Because in the POCO, there is an ID property. When we call JSON serialize this object, we don't have to say remove the ID property. We just say, whatever, save the ID with that. No, maybe I didn't understand the question.
That's clear. But couldn't you populate that ID property from the ID column?
This is what is done when we load the object. When we load the object, we have the person, which has an ID deserialized from the JSON document, but we will assign the one from the ID column. It will be the same value, but the ID being optional, we don't care. If we find it, we assign it. They will just be the same value.
It's wasteful.
It's just about storing two times.
No, but it's more work not to store it. That's what I'm saying. Because when we serialize in JSON the object, we will have to remove the ID property from the JSON document. Okay?
Right. Okay.
And it's more work than just saying serialize the value. Well, don't. It's more C# work to just say go to the property and remove that. I mean, we could, but who cares? So do a performance test and show me that it's faster, and we'll change it. If it's the same, we don't care. Let's do nothing. Fix only what is broken. It doesn't. And maybe one day we will care, like, oh, it's actually interesting to have the ID property inside the JSON document because it's good to be there, and we don't have to do the jump to taking the ID value and putting it again on the object. So maybe I will leave it. Maybe there's actually a reason to leave it. I don't know.
So if I understand what you just showed correctly, then the database ID is really only for mapping between an index and the document,
Yes,
right?
yes.
So on the data access level in our code, we don't actually have to care about those IDs at all.
Most of we do, because it might be optimized in some cases to just say load the document ID number 1, and this is what actually internet.
But so that was going to be a follow-up. So if I prefer to ID my documents by something else,
You
like
can.
an alias or
Yes,
I could just put that as a property.
and you project it into an index which will be your content item ID, and this is what we do in Orchard 2. And in Orchard 2, this is what we do. We have an index called content item index, which has the content item ID, which is a string, published, latest, and modified it. This is an index. We are projecting the content item ID known properties into that, and we query by that. We don't care about the database ID, because the logical ID, of which is a content item ID, will be fixed, whatever database it is. And this is why we have a content item ID.
Right, and in that case, I don't ever have to even see
Correct.
the database ID.
Yes. And that's,
Do you even have to have the property on the POCO?
you need to have you don't need to have the property on the POCO. You need to have the property on the index only, because you build the indexes properties based on whatever you want, even if it's a dynamic object or whatever.
So it's an implementation.
Right, yeah.
You have 5 minutes? Eric or Brian, whoever you are. 5 minutes? Yeah.
5 minutes forward.
Something else. Good? Bertrand. Thank you.